So my name's Grex, for those that don't know me, and I run a small website called novainfosec.com, and I also work for a big DoD contractor. Just wanted to thank the sponsors for this year. So the platinum sponsor was Cobalt Strike. This is anyone familiar? Has anyone used this tool? It's awesome, right? So are there any local folks that have heard of Mach 37? Well, yeah. So Mach 37 is a local, I'll say it because Bruce said we can say it. It's a cybersecurity startup incubator. So, but Bruce said we could say it. Yeah, we had to say it. And then, so they were the gold sponsor, and then the silver and the bronze sponsor, they just merged in and got both slots. Was a good friend of mine, Jason Oliver, started up a company about 6 months back, well, it's been more than 6 months now, it's about a year, but called Tigris, and they do consulting and compliance stuff for the US government. So just want to thank you to them. We have some awesome giveaways, which I'm going to throw out here as we go on, and I'm going to probably save most of them until the end, so it'll force you to stay longer, but no. And then, so we have 6 or 7 speakers, and so we're going to go and judge them, and then we have prizes for the first, second, and third places that we're going to announce at closing ceremonies tomorrow. So, was anybody here for the first 2009 Firetalks? No? Yeah, so this is just essentially a shout out to the people that started this whole Firetalks thing. I don't know, the people that initially came up with the idea were Michael, and I can't ever say his last name, but Santar Cangelo, or at Catalyst, and also Mubix too. And there were some others involved there, but this was started in 2009. And the great thing about this is it isn't just ShmooCon, but I think like every conference that we go to, there's some sort of a Firetalks track. So I always like to give a shout out to them to see where this whole thing started. So I mentioned Cobalt Strike is our platinum sponsor, and then our Mach 37 and Tigris for the other sponsorships. Thank you. And I also wanted to thank our sponsors. So we have Iron Geek, who's doing the recording once again, so you can go to his site and see these videos after the fact. And then for just security and just helping me out, we have Tess. She's standing back there, so thank you, Tess. And we also have Ideas New Now, so he said I could pronounce it however I wanted to. So, but yeah, thank you. So this is the schedule that we're going to be going with. So the first talk we're going to be giving is by Robert Simmons. This was a talk that I saw him do at B-Sides, Delaware, if anyone saw it there. So it's a great talk, basically creating a framework so that you can scan, you can get multiple AV files or multiple AV products and use them together so that you can scan files. And so he's going to talk about that. Robert? Okay.
There we go. All right. Good evening, everyone. My name is Robert Simmons. My talk this evening is on my project Plague Scanner. And this is the first slide. Who am I? My name is, my handle is Utkanos. It's Russian for duckbill platypus. Why not? So I'm a senior threat intelligence researcher for Threat Connect. I'm a fresh person there. I've been there for 3 months now. It's a wonderful place to work. I love them. My Twitter handle and email address are down there. So what is the problem that I'm trying to solve here? So let's say you have a spear phishing attack, and the information that's in the PDF or the doc or whatever it is that you want to scan has sensitive information about the company where you work. So this poses a bit of a problem where one solution is to upload the file to an online multiple AV scanner site. We all know the name of it, but I'm not going to point any fingers at anyone. But online ones, that's a problem because you're going to be sharing that file with me. I don't think you want to share your company's private data with me and anyone else that has a back-end intelligence login for said online site. So that's a bad idea. The second solution is, I'm also not going to point fingers at them, but there's a very, very expensive on-premise multiple AV scanner. So it's very, very expensive. So that's another, unless you're a big company, another non-starter. So solution number 3 was the way that I took. And so it's create an open source multiple AV scanner framework and share it with the world. So just to go over some of the background of this, you might all recognize this bar at the Rio. This is where I started formulating the plan. I was speaking to an engineer from Apple and another guy who's a sysadmin at DataSift. And I was talking to them about the whole idea of this, and they said, well, it's a good idea. So after a few rounds of drinks, I decided to start the project. So here are the basic components. The entire project is written in Python. And it uses the YAPC plugin system. You may recognize this from Mastiff, which I think 2 years ago there was a ShmooCon talk about Mastiff. Great product, by the way. It also uses 0MQ for messaging in between the VMs and the central system. I utilize QEMU and KVM. This is just the first step. I would love to have other virtualization systems available, but this is just the first one that I chose. I use kernel same-page merging for memory deduplication, so that's a component of KVM and QEMU. I use the Pillow Python image library for doing screenshots, and I'll get into why I do screenshots a little bit later. And I use Tesseract OCR. And the output is JSON, and the reporting can be exported to Elasticsearch, because Elasticsearch is awesome. So basically, you bring the scanners. This is my sort of caveat. You bring the scanners, and you bring all the licenses, because that's all closed source stuff, not something I want to get into. So you bring all the stuff, and I bring the plugins and all of the instrumentation for each of the scanner engines. So there are basically 4 types of scanner engines. I know there could be a 5th here, which is an online one, but I don't want to really have it connected to anything that's online. So the first one, open source, such as ClamAV. The second type of scanner engine is one that has a Linux version, so it makes it fairly easy for me to instrument it and get output from it. The third type would be a Windows only, where the scanner engine is only available in Windows, but there's a CLI. And then the fourth is a troublesome one, or some that have a GUI. I don't want to point any fingers at this time, but you know they are out there. So GUI only is the fourth type. So why do I have OCR in here? It's for that fourth one. So if there's a scanner engine that has a difficult interface, or if it's just got a GUI, then I would take a screenshot and then run that screenshot through OCR and get that data out and put into the JSON file output. So this is a bit of a very simplistic architectural diagram of how I have it set up. So up at the top is the submission, processing, and reporting element. The message queue is the little cloud there, and so that sends the jobs out to the various VMs, and I have a little agent in each one of the VMs. I wanted to make it easy for people to use. So the setup in the VMs is, the agent is kind of stupid. So it doesn't know a lot about the scanner engine. It actually gets the intelligence of how to use the scanner engine in the message queuing. So the person who's setting up each one of the VMs doesn't necessarily need to know too much or figure out, I don't need to have like 30 different agents for each one. I have one single agent for each one of the VMs. So some of the really cool features in here, like I said earlier, it utilizes kernel same-page merging, and if you're familiar with this, this type of technology is utilized in a lot of different virtualization. It has different names in different types of virtualization, but it allows many VMs to share a lot of memory pages. So it deduplicates, and anything that has a common memory page among different VMs, there's only one copy of it that's used in the hypervisor level. So another thing that I love is ZeroMQ. It's a great message queue. I know a lot of people might use RabbitMQ, but I don't like the idea. I prefer ZeroMQ. I think it's very fast and very, very simple to set up. And of course, Elasticsearch. Elk is awesome. I love the Elk stack. So it allows you to do, if you have a historical set of output from the system, you'll be able to do statistics and any sort of fun data science with it. So some of the open issues that I have right now, is daemonization. I would like to have something similar to other projects where there's an actual running daemon that sits there and receives and does the refereeing of the entire thing. Also, I haven't really solved the scanner updating problem because it's like herding cats. Every single scanner wants to update in different ways, and how do I want to have that work? It's not a solved problem yet. Also, I'd like to have resubmission automation so that if you have something that comes back with 0 hits from any of the scanner engines, you would be able to have a resubmission at a certain period of time so you can see if one of the scanner engines eventually hits for the file that you're looking at. I also, if you're familiar with the HoneyNet project, there's a protocol called HP feeds, which is awesome. Both the Thug project and Cuckoo both use HP feeds. And it's a publish and subscribe protocol where anyone that has an instance of my Plague scanner would be able to turn on HP feeds output, and then you would be able to subscribe to that feed and get whatever I decide to have in the feed, whether it's the binary itself or whether it's just the JSON output or the data output from the system. Another thing is I want to develop some relationships with AV vendors. I know if anyone in the crowd works for an AV company, please come talk to me. I'd love to bend your ear. And then also, of course, one of the main problems of all time with open source projects is money. So if you want to write me a check later, please come find me. So I'd like to give, at the end of my talk, I'd like to give a little shameless plug to my employer. So we have a free level account, so please sign up for a Threat Connect account. I love working there, the place is awesome. And so for the last couple minutes here, if you have any questions, I'll leave you with a really cute picture of an Utkanos. Also, one more shameless plug. I need to thank the designer that I have, Wintry Gray. He's at 99designs.com, so he did all of the facelift for the project, so he's awesome. Sure.
How many engines have you successfully been able to have running?
Very good question. So right now I have 15. They're basically the ones that I've chosen as being the most beneficial or the most valuable. I aim to have the same number that the online site has, sorry, I like to aim for the same number of scanners they have, but they have some that are very obscure. There's a Chinese company on there, and a Vietnamese, I think. I probably won't ever instrument them unless someone has a request for it. Yeah, there's a couple of very obscure ones that they work with. Yes, so I'm actually having a little bit of hosting difficulty, so there's still a parking page on my site, but it'll have content at some point today, tomorrow. I'll go back to the front so you can see it's the same, same domain as my email address at the bottom. Uh-huh.
Based on what you tested, is there any particular engines that you found to be more, better at finding people, if you will, and ones that were worse?
It's a good question. So where I worked before, I worked on their automated malware analysis lab, and we had the very expensive bank. And so I actually, my employer and some of the other researchers on our team had done a paper a few years ago just about that, like how good are some of the virus scanner engines. And actually that company got into a little bit of a public fight with one of the scanner engines because they were saying that we didn't give them a very fair shake, where most of the submission, like my whole system right now is basically a static analysis system. So their big complaint was that they have, you're actually running the malware in your system if you're unlucky enough to do that. And so they have heuristics and sort of active analysis in their scanner engine, which will which will block things that it wouldn't necessarily block just by the static signature. I hope that answers your question. I don't like to name names. I don't like to point fingers.
Was that paper published?
Yes, it was, but I don't work for that company. You can come and talk to me later. I'll tell you where it is, but it's my former employer. So.
Question.
Mm-hmm.
So how are you looking to update these? Because again, like you do a lot more scans, but most of them have a scheduled update, or is that not a week for you, or like where do you?
So that's a good question, and like I said, that's one of my unsolved issues, and I'd love to have help with that, so contact me, help me out in the project.
How robust is your support for executing the sample?
None. I don't execute the sample at all. That's what, like I was telling him, I would like to, in the future, have the system do more dynamic analysis where I actually execute in the VM, but right now it's just a static file scanning. Thank you. That adaptive, so somebody needs it.
All right, so we were talking about the Neo a little earlier. Does anybody want a Neo? Yeah. A Neo, the YubiKey Neo. All right. Hey, there's somebody's phone here. Let's see what's going on. No. Wait a minute. Let's answer it. Oh, come on. Hello.
My egg timer.
All right, so this is awesome. So the YubiKey Neo, it's pretty cool. Now, this is going to be tough because it's very lightweight. I have heavier weight things later. Damn, $50. All right. So next up, we have Will Schroeder, and I forgot, what was your Twitter name?
Harmjoy.
What?
Harmjoy?
Harmjoy. Yeah. And he's going to be talking about iHunt sysadmin, so I'm looking forward to this. Cool.
So I tried to go with the trolliest talk title for ShmooCon that I could come up with. If anyone knows why this is funny, then I heard a few people laugh. So my name is Will Schrader, and my handle is Harmjoy. I'm a security researcher and red teamer for the Adaptive Threat Division of Barris Group out here in Virginia. I'm a co-founder of the Veil framework, and I'm a founder of Veil's Power Tools, which is the offensive PowerShell component. I always ask this, but how many people use the Veil framework on a regular basis? Cool. Awesome. I've talked at a few cons. I was on the stage last year, Christopher Trunser, talking about AV evasion with the Veil framework. So all this talk is ways to hunt for users on Windows domains. That's it. I'm going to cover as many tools and techniques and a bit of the tradecraft as I can. I'm going to go over kind of the old school way, and then the PowerShell stuff is going to heavily factor in some of the later methods. So this entire talk is from kind of the assumed breach perspective. I know Microsoft had this great Office 365 red teaming paper they came out with talking about this, companies need to assume that they're already breached. So we do a lot of kind of post-exploitation or post-compromise, post-exploitation type stuff. I'm also going to assume that you more or less know the users you want to go after. And some of the PowerShell methods you can query for user groups and stuff like domain admins, but you're not always hunting just domain admins. The PowerShell methods are going to heavily utilize PowerView, which is one of the tools that I wrote over this past year. It's like a network situational awareness tool. And, the link's on there. These slides are actually up live on SlideShare, and I tweeted out from my handle, Harmjoy. So the motivations for this, like why would you actually need to hunt for users? Every single engagement that we're on, at some point we need to find where very specific people are logged in. A lot of times, if you have a local admin password, or if you have some kind of desktop admin privileges, you want to laterally spread. This is the classic, fish a user, pop the box, get the local admin, see where it works. Used to in the past, we would have to do, like a lot of scanning. Maybe you manually put an interpreter in each box, trying to figure out, almost sometimes by luck, where these particular high-value users are logged in. So again, hunt, pop the box, mimikatz, repeat. Another time is if you already have domain admin privileges, you might want to hunt down where very specific people are to demonstrate impact. Think popping the CEO's box, getting their email. We really like to go after incident response teams and then dump all the rules and see what they're actually able to detect. So it's kind of the point of the title. Again, a lot of assessments, we like to really demonstrate impact. A lot of CEOs I don't care if you got domain admin, but if you can show them, like you guys know, you can show them their email or something like that, it drives the point home a little bit more to them. So where are my sysadmins at? Finding your prey. There's a lot of tools that have been out there for a few years, some from Microsoft, some from other vendors, that will let you do this kind of searching. I'm going to cover everything that's out there, along with the positives and negatives for each. I'm going to go relatively fast, but a lot of times this boils down to, do you need local admin on the remote machine you're enumerating, or do you not? And I really like this term, offense in depth. You always want multiple ways of achieving the same component of your attack chain. You don't want to hit one step. You're trying to hunt for users, and like maybe AV catches the executable you're using, maybe PowerShell is disabled, something like that. So I like having options so you can fall back and always be successful. First tool, this is PS Logged On. It's a component of sysinternals. It determines who is logged in by scanning remote registry stuff, as well as using the NetSession-enum API call underneath, which I'll talk a little bit more in a moment. Again, because you need this remote registry access to determine who's logged in, you need admin privileges on the machine that you're enumerating. This tool can kind of automatically pull some target hosts and stuff from Active Directory. And the links down there is just sysinternals. So this is kind of what it looks like. PS Logged On for for hunting for Chris Trunser or something like that here on the domain. You see it's going to enumerate all the hosts, and all this information is going to come back based on remote registry. We used to use this for a while, but again, you need local admin on the boxes you're running it against, so that really kind of limits the times you're going to be able to use this during engagement. NetSesh.exe, it's a part of the Joeware toolkit. These have been around for almost a decade. This is really awesome because this NetSession-enum API call that I mentioned, it's essentially like a net session that works on remote machines. So you can run this against a file server or something like that and get a really good mapping of who's connected back. It's really useful if you use it against a server that a lot of people connect to, which I'll go over some of that in the PowerShell stuff. And what's great too is you don't need admin privileges on this. You can be unprivileged user, and and for some reason Microsoft decided that they'll let you get all this remote session information. You need to be a domain user, but you don't have to be privileged. This is kind of what it looks like, running against like a file server or a DC or something like that. Some more people have lots of sessions. You kind of see this username, this domain is logged in here from this particular address. So we've been using this for a couple of years. It's pretty effective. I'm sure some people in this room have used it as well. A disadvantage is it's an executable. You have to drop it to disk. You have to get the raw data back from an output file and parse everything manually. So you can get the information, it's just not as nice as some PowerShell stuff. There's a tool released by Cornland Coder. Really cool tool, PV find AD user. It helps you find where AD users are logged in. You can also check, like the last, through remote registry stuff again, check the last logon user from a particular key. But even states, like in the description, you need admin access again. Again, like I said, kind of two classes, need admin or not need admin. The link's down there. It's off his Corland main page. You kind of see here, you run it. It'll enumerate all the machines in the domain again. It'll process particular host. We've used this a few times, but it again, it's kind of limited. It's more or less only kind of useful if you already have domain admin or desktop admin or something like that. NetView.exe is a really cool project from Rob Fuller, as mentioned earlier. Presented at DerbyCon 2012. It's a C++ project that enumerates systems using Windows API calls. So underneath the hood, it uses like netshare num, netsession num, networkstation num. So you can get remote shares, you can get remote sessions, and remote logged on users. The networkstation num API call doesn't really have kind of a native Windows tool equivalent. You can also check share access, highlight users, and use a delay jitter and things like that. You can get a lot more information if you have local admin privs on the particular box that you're enumerating. But for a lot of this, you don't need remote admin. So we started using this about 6 months after it came out. Super awesome, super effective. It's very, very fast, but it generates a lot of traffic because it's going to touch every single machine on the entire network. Most places aren't really going to detect this, but there's a couple places that they're doing kind of IDS heuristic stuff. If they see one host touching every single other host by SMB, it can even trigger like SMB worm rules and things like that. But really cool tool. It's actually kind of the original inspiration for some of the PowerView stuff. And it looks like you run it, there's a whole lot more output, but enumerates all the machines, gets every single box. You see the shares and stuff like that too. The remote session, remote logged in users. There's also a function now that you can specify a domain group, like domain admins, and it'll like highlight with the specific flag saying, this user you might care about is logged in here. Again, a ton of data, and it can take a while sometimes. It's really nice, but C++ isn't quite as flexible as something like PowerShell. If you're on a Linux box, you can use this pretty cool SMB and num users in a C script. You need some kind of valid local account or a valid domain account to get the information from a remote machine. But it does that same kind of session enumeration against remote boxes. Because it's nmap, you can specify all the targets you want and do all those typical types of things. It's pretty cool. We use it a few times. If you're on like a local pen test and you have just like a Kali box with a tap or something like that, you can use this. What it looks like, you get those raw results back. You're going to get a lot of information. And one thing we've done before is if you fat finger the password here, you can very easily lock out accounts across the entire domain because it's trying to run. Like, I'm not saying I've done that, but awesome account lockout. Another kind of cool method that we've used a few times is if you pop a user and you have access to their internal email somehow, whether through OA or whatever the portal is, search for other emails from other users and check the X originating IP header. This isn't always present, but it sometimes is. So, we've done this to find like IR guys, looking at, they send an email out about an incident or something like that, and you just check the headers, and like, oh, I think this is the range where all you IR people are, So PowerShell, Microsoft's post-exploitation language. If you've ever met me, I won't stop talking about PowerShell. The PowerView, the tool that I wrote, originally had a port for invoke, NetView, and things like that. I started playing with this functionality and realized, we hunt for users all the time. Why don't we just do some PowerShell methods for this? The user hunter will query, it's super, super flexible. It'll query domain for all users or a target list. You can do a single user list, whatever you want. Same with a host. You can query the domain for all the hosts, just host in specific OUs. You can do a list, anything like that. Delays, jitters, all that flexibility. Underneath, it uses the same API calls. So in PowerShell, it can get a bit tricky, but you can get access to the lower level Windows API. So using this net session network station it'll query all that to every machine and then match up against the target list. You can also check if you have local admin privileges on the boxes you find. So sometimes we just run this, come back 20 minutes later, and then we know exactly where domain admins are logged in, and if we have access to the box, then we can just pop it pretty easily.
How's the query AD?
Sorry?
How's the query AD?
It's the ADSI accelerators or whatever. PowerShell is like hooks and stuff into AD. It's meant to be, a management language, so it's super, super easy to get hosts using those particular AD queries. This is what it looks like. You can run this whether if you're like actually physically on a box, RDP, or through your particular agent. So Stealth User Hunter, this is one of my favorites. It uses a old red team trick where it queries Active Directory for all user objects in AD. It extracts the home directory fields, which in a lot of organizations are where file servers are specified. It unifies that list and then enumerates sessions against all those, checking against the target user list. So you get maybe like 60, 70%, like kind of decent coverage. It's not going to be as accurate as User Hunter because it's not touching every single machine, but it's much, much stealthier. You have one queried Active Directory and then just a handful of kind of session and num calls against some file servers, which they have a ton of SMB traffic. We've never seen anyone detect this. I don't see how maybe they could, but it's essentially using kind of native normal functionality. And again, no admin privs are needed. Pretty cool. You see here, like kind of in the background, it's enumerating the users, extracting the file servers, checking for domain admins, like Chris. One other method that we came up with recently is offensive event parsing. So if you already have domain admin privileges and you can query the event log in a domain controller, there's no reason that you can't just pull out all the login IDs and say, oh, here's where each single user is logged in. Again, you need domain admin privileges pretty high. We like to fall back to this, kind of use it once we're already to that point that we get DA privs when we want to find IR guys or CEOs and things like that. So get user login events in PowerView, implements 6-dubs work, he's presenting right after me. And the invoke user logon hunter will weaponize all this up into a really nice scriptable form. This is what it looks like. You just run it. It's actually going to, in the background, enumerate every single domain controller on the domain itself. Go to each one of those, get all the event logs, and then parse that and check for a particular user. By default, if you don't have like that username flag, it's just going to go for domain admins or whatever group you want. So this, you can do this manually. We've done it manually. It's kind of a pain to search through. There's a lot of event logs in domain controller. So PowerShell makes it pretty easy. It's actually a pretty short section of the script. And that's it. I'm kind of fast, but any questions for a minute or two? Yes. Can we use wildcards for which part?
When you're invoking it and you're doing this.
Yeah, you can use, I think there's multiple ways to specify like machines and things like that. You can use wildcards as part of the names, or OUs, and I think for users you can do like SPNs, service principal names and stuff like that. If anyone has any more ideas for like the ways to get the particular targets, just let me know or hit me up in an issue in GitHub or something. There's also a couple methods that you can search for groups of interest, all by wildcards, like search any group that has Linux in it or admin in it and things like that. So.
I mean, does that any tools rely on the NetBIOS protocol?
No, there's no NetBIOS. It's one other method. We've tried that. It's kind of been unreliable in some domains. But yes, so the question is, do any of these rely on NetBIOS? There's a couple tools out there that do it, NBT scan and things like that, but we just haven't had as much luck in newer Windows domains, like the 2008, 2012 type stuff that's locked it down a bit more. So, any other questions? Yes.
For speed, do you find stealth user hunters a lot faster?
Yeah. So that's a good point. The question is, do I find if stealth user hunter is a lot faster than the user hunter? It definitely is, because if you're on a domain with thousands and thousands and thousands of machines and you're trying to do these enumeration protocols against every single one of them, it can take hours to, it can take a while. Stealth User Hunter, because you're enumerating all the user objects, even in a giant domain, that doesn't take that long. And I think the max we've really seen is maybe 20 to 30 file servers. So it goes really, really fast, usually like 3 to 5 minutes, something like that. Yep. Cool. All right, that's it. Thank you.
Somebody's leaving. Oh no. All right, I have a throwing star thing right here for the gentleman that's leaving. No. All right, so I got to go over here. All right. Guys up. So there was. Have you seen any of these? Does anybody know what this is?
No, but I want it.
So this is a little different. So you know those USB condom things where they basically snip 2 of the 4 wires so that you can still power it, but there's no data, right?
Yes.
Right? Well, so this is a little different because no, it doesn't have a key. It doesn't have a key debugger. Those were too expensive to get, but they were like $150 each or something. So, no, but this is a special one because whenever you cut those wires, you only get trickle charge. Where this one is, you can see it's a little thicker than the normal one, but it's, but you actually get the full charge. So let's see over here. All right. Oh. All right. All right, so next up is we have Justin Warner. So he's doing collaboration scanning with Minion. Sharing is caring. Justin?
Hello, everybody. Awesome, welcome to the talk. I'm going to start. I go by the handle 6dub. My name's Justin Warner. I'm a cyber guy from the Air Force. Drink. Just recently busted out the private sector, and I'm loving life. You can pretty much echo what Will said. I'm a red teamer, penetration tester for Varus Group. Have a really good gig there, doing lots of fun things, long-term engagements and other things. I have one non-nerd hobby. I'm a volunteer EMT in Fairfax County. I try to mix it up a little bit, but that's about it. Everything else is hacking. So I do a lot of CCDC and defense exercise type of events on the side. And this talk was partially inspired by that and partially inspired by starting my new job. And what I've seen over the past couple of years doing these events is a massive move towards collaboration. 4 years ago when I would do these events as a red teamer, blue teamer, it was a lot of hoarding shells and always having to go through one guy to get the information, and no one wanted to share, and everyone would just go sit in the closet and work by themselves. And it wasn't quite fun in the red team room. As this has changed, it's been a lot better. Everyone actually uses tools in tradecraft that actually work together. Things like Dratus Pro, Cobalt Strike, Metasploit Pro, they allow for that team-based collaboration. The one area I still see that doesn't exist is in scanning. You'll still see people use Nmap on their own box with save the data local. There's no major popular framework that's using these exercises that allow for them to share this data, query it easily, and do it in such a way that's distributed. This is what I think of nerd collaboration. I still see it like this. This is exactly how it looks in the rooms. So distributed scanning is nothing new. It's been around since I can see the late 90s from everything I was able to research. It's basically the idea of using like a botnet style architecture to do your scanning. Some of the earliest things I could find is something like RNmap, an old, really sexy old school GUI that allowed you to do this. It was written in Python. Various POCs dropped on the internet after that, and then DNmap in 2009 came out by Sebastian Garcia. And it has a really good working proof of concept that I use for the back end of my framework. Most vulnerability scanners, Nessus and other things do this as well. They have some sort of distributed component that allows it. And there are multiple benefits here. Obviously, it depends on your situation, whether you're doing penetration testing or red teaming or vuln scanning, but they're all up there. It's not a silver bullet. IDSs do have distributed scanning rules if they're enabled, and if they're tuned properly, obviously that's a big thing. It has to be able to detect it. So DNmap, a little more on that. It was developed by Sebastian Garcia, and it's a really awesome working proof of concept. I stumbled upon it and kind of dove in on the code. There's a lot of to-dos he had in the headers, things that he wanted to work on that weren't public. And so that kind of guided my inspiration. I was like, man, I should jump on this and work with it. It was already using SSL for encryption. It works with Python and Twisted. And the things that didn't work for me particularly were there's no .nmap output that was used. I'm sorry, .nmap was the only thing that was returned. And so we use tools like Eyewitness or Peeping Tom to do a lot of our penetration testing automation scanning for like web that uses a gnmap output. And so this tool wasn't giving us what we needed to do that. There was also no client authentication. So if you had a server up on the internet, sorry, this is the diagram of how it works. Pretty simple. Box, call back to server, you submit scans, it submits it out. All command line and built in. So like I was saying, there's no client authentication. So if you had a server out on the internet and you had some really frisky incident responders that wanted to come find you and they just located your scanning server, it was as easy as OpenSSL client connecting into your server, recognizing its DMAP and issuing the right commands and just watching them dump all the scans that you had queued up. And that's no good. I mean, I've been actively queried by incident responders in several engagements now where they actually come find our staging servers or come find our web servers. And you know, when they steal all your data, it's no fun. Big black eye for the red team. And so one of the first things I wanted to fix and kind of improve upon, which DMAP highlighted as something that needed to be done, was implement that client authentication. So I started to tiptoe into it. Basically what I wanted was a distributed team interface scanner, synergy. I wanted everyone to work together and be happy. I wanted something really ideal. Had to be secure. I wanted to implement that client authentication. And I wanted built-in management capabilities. I didn't want to have to SSH out to all my nodes in the server every time we wanted to do something. Just waste of time on an engagement, and sometimes we're limited to a week or a couple days, and so it's not really where I wanted to use my time. So I came up with what I call minions. It's a collaborative distributed scanning. I call it a proof of concept. It's a work in progress. By no means am a professional software engineer or developer. And so really wanted to make this a team project where we could use for everybody to get involved. It's a Django backend. I found that useful because it's really simple to throw up a proof of concept. Python, I knew Python pretty well. I'm not a Ruby guy, and so I didn't dive into Ruby on Rails or some of the more evolved languages. It uses a DNMAP, a modified version on the backend. For the distributed scanning, and it has a Bootstrap jQuery front end, pretty much default Bootstrap, nothing fancy, but I found it really good because it was responsive and worked well for mobile. And so I've actually sat in a bar or two and popped on my iPhone and gone out to my Minion server to send off scans and do work, all from the comfort of the bar. Some of the features that I implemented, I was able to execute scan jobs, per se, so you could schedule them, no more coming in at late nights to do your pen test and kick off scans because the client-customer environment would be affected. You just schedule it, uses @jobs on the back end to kick them off. You can create scan profiles. A scan profile is basically the idea of something you always do. So, Nmap command line has some pretty elaborate options, and having to copy-paste the same thing over and over again or type out the whole thing over and over again, it was boring to me. And so I implemented this thing called scan profiles where you can create them and save them off, and when you actually go to create your scan job, which you'll see in the demo, if I get to it pretty quick here, you can just kick it off and go. And you can download all the different scan outputs, which is one of the main features. This is hardly Pythonic. Like I said, I'm not a software engineer, but I added the ability to pull for those Nmap output files and bring them into SQLite database backend, and added the client authentication, as I already said. Some pretty interesting use cases that I thought of, so external penetration tests. Obviously, there's things like MassScan or ZMap that are really good. But this could also be used when you're distributing your scan jobs. It makes things a lot faster, more efficient, and you come from a whole bunch of different locations. Internal penetration test, you can make your designated scan person, aka the new guy. You can make them run. The scan server and use all the client or use all the engagement laptops. And so you can split up your scan and get a lot done. External red teams, this is actually why I created it. Hide attribution, have 100 different scanning nodes across the world in different countries so that the IDSs and the network defenders don't really see where you're coming from at all times. Internal red teams, same kind of thing. You can compromise internal Linux servers, throw up your the client script in Nmap, and now you're turning their infrastructure into your scan bots. Some extra fun things. Ken Weston, I read an article about using DNMAP and doing the Linode stuff, and so I actually wrote a stack script on Linode to automatically download and start in the scan bots, and so I could use the API with Python, kick out 100 scanning nodes would immediately pop up and call back to my bot, which was awesome, and it would look like this. So you'd have this crazy in-depth interface full of scan nodes ready for fun. And so I'm going to try to break out here and get to the demo, which is more interesting. Yeah, right. guys got that. Let's do that. And so basically what we have here is the three windows. The left window is going to be our DMAP server just after I did the install script. The IPs there. These are internal IPs, obviously for demo's sake. I did it with a couple VMs. The upper right window and the bottom right window are going to be the DMAP clients. You can see their IPs. I've already downloaded the code and it's sitting there ready to be run. Normally you don't have to be SSH'd out. This is the purpose of the demo. I wanted you guys to be able to see what it looks like if you're actually watching the command line output. This is the tool. When it comes installed fresh off the install script, it has a default password, so you want to log in, go access the Django interface. I left the Django default admin interface. I wanted people to have the raw access to the data on the back end. They don't want to hide anything. This is a hacking tool. Hackers like to have raw access to data. And so didn't do any major changes, also a proof of concept. So go in and change your password, definitely the first thing you do. Don't let incident responders win. And I fail, so humor's sake. And so once that's done, you're going to come back out to the main minions area. The first part I'm going to show you is the server control. So in the server control, this is the area that you do all the backend DNMAP stuff. So this is where all the buttons to clear all the output, clean up everything, start and stop your server. It's pretty much everything you would need to get up and running. There are different permission levels, so admins have access to all these buttons, non-admins don't. So maybe you don't want your new guy going out and clearing all your data from the whole year and it hasn't been backed up. That would be bad. So I went ahead and started the server there, and I'm going to connect to the clients just by doing the Python command line. You can see it's a Python script. It does have some install dependencies, and mapping the most obvious, and it kicks on pretty easily here. Now once these are connected up, you'll see that you don't have to sit in this SSH interface, as I said. You're going to go back into the admin area, and you should see a pretty simple interface to see these clients. Just so you know I'm not lying, that they're actually connected, I'll do a net step for you. Yay. So here they are. So you can see that Minions 1 and Minions 2 is connected there. They are nodes running the nmap script. And you can see some information. Obviously there's verbose logging, so it tells you the IPs they connected from in case you ever have a client ask you questions on it. And you can see that we're going to go on to the run scan area. So in this area is where you actually create your scan. It's a pretty simple default Django form. And then these are scan profiles. So these are the things I was telling you about with the different command lines. So profiles, like I said, are the different command line options. You can create a new profile. So we're actually going to create a profile today for web scanning. I'm going to do a really simple version scan on port 80 just to demonstrate the profile use. And they save. So if you have your crazy, wicked command line options, just save them off and use them next time. So we're going to do a scan of a web server I had running out called DFM Web. And it should be just a simple web like Apache server that we're going to scan. You can see that the time there is always set to instant. So these scans are set to go off immediately. If you were to change the time there, that's when it would recognize that you wanted to schedule a scan job and actually do it on the back end for you. All right. And so I created one that was going to go off instantaneously, and then I created a second that's going to be scheduled for you to see. So you can see in the bottom right, the schedule job is sitting waiting there, ready to be run. And in the log here, you can actually see that the first scan we kicked off immediately went out to the node and finished. So this is what the output looks like. By default, you can see the nmap command line output, and then you can see some of the metadata that I pull out and tag and parse into SQL. You're also able to download a zip of all the different output formats. It packages them up for you on the fly, and there you go. So you have all the outputs ready for you to use. You can also delete the scan in case you don't want that. Maybe you screwed up or you just don't want people seeing what you scanned. So we can come back to server control. We're going to still see that the scheduled job is waiting. Nothing more going on there. It hasn't hit the time yet. So we're going to run 2 more scans here so you can kind of see the whole multi-node thing in use. So we're going to run a nice slow scan. This is going to be like a 65,000 port scan, full thing. And we're going to run a faster scan, like a top 1,000 ports. And what you're going to see when we come back to the control area is you're going to see both clients are going to get these executed scans, and they're going to be running in parallel. And so if you had lots of scan jobs, lots of clients to do, you could distribute the scans out to different nodes and do them all at one time using the same infrastructure. You can see the pending jobs is holding that one that hasn't went out to the client yet, so you'll actually watch it get picked up and go out. Now they're both executing. Now let's say a client dies, because that never happens. We can actually kill a client here in a second, and you see all the results come back. Sorry, a little out of order. So the fast results came back, same thing you've already seen. Now let's say that a client dies. So we're going to go ahead and kill this client down here, bam. And you'll see that the scan that was at that client is repopulated into the scan list. So I did build in some amount of redundancy. Obviously, the plan is to like leave these nodes up on the internet for long periods of time and not have to sit and maintain them. And so I built redundancy on both the client and server side. If a client dies, the scan's repopulated in and gets picked up by the next available node. And if the server dies, which I'll kill it here in a second, you'll see that the scan that was currently ongoing gets repopulated in and will get picked up whenever the server reconnects. By default, when these die, the clients will attempt to call back every 10 seconds. So they'll sit and beacon and come back until you start the server and get it back up. So what you should see here is the clients connect back in. Awesome. And so that demonstrates the different redundancy options that are available. And that's about it on the demo. It's not a huge tool. It's meant to automate and make things a little bit easier for these long-term scan operations for red teams that do this against different clients. Come back. So here's my contact information. I go by 6dub on Twitter and GitHub. The code is already out there. And my blog has a post kind of detailing everything I just talked about in written form in case you fell asleep. And then I also hang out in Freenode on the Veil and Armitage channels and Veil Developer, and can hit up there anytime. Some references, if you guys pull the slides down after line, they're on SlideShare, kind of where I got some of the information. And that's it. Does anyone have any questions? Oh, yeah, no problem. The contact slide or references? So the top link there is the Ken Weston article. It's awesome. It was one of the cool things to write. And the RaiderSec blog just has a detailing of what DMAP is and the diagram and stuff I pulled. I want to make sure they got quoted. Sure, go.
How many minis can you control for scanning?
So I load tested it with 100, and it was easily doable and had no problem. As many as your server could handle, I guess, would be the answer.
So have you thought about automating, you set up a scan, automating your scans, you set up a way to just dump it to like a file share or to disk, so that maybe it can be picked up by someone else? So I'm more defensive. I'm like, oh shoot, I could automate my flipping network scans,
Sure.
upload lists of assets every week, every day, and then have something pick up the file or automate do something else, maybe a report or something like that.
Sure. Yeah, so the scans are all stored on the server in their raw like scan output formats. And so wouldn't it be hard to do some sort of automation on that server, like an at job or something, to pass those over SMB or to pull those off, FTP them up, SSH them up? I haven't built it into the client now, but I'm open to suggestions. So I love ideas. If you submit them on GitHub or email me on the side or chat with me, we could talk. But yeah, I'm glad to see that it has use on the defensive side as well.
So, kind of related to that is a comment that the defensive side, long-term engagement, I think you'll see diffs from one scheduled scan to the next or changes over time.
Sure.
And another question I had is, do you have anything or have you thought about anything for when privilege escalation is required for scans to require raw sockets or otherwise, your pseudo nmap kind of things?
Sure, yeah, the DMAP actually has built in the detection to see if the client's running as root, and it will, a lot of times it'll error out if it's not running as root. It kind of expects your clients to be running as root. The reason being, these clients on the offensive side, a lot of times are throwaway. Like, I'll spin these up for an engagement and do my scans, and like they can just be taken down, especially with Linode, we pay by minute type of things. And so I don't have that built in. It would be something that could be worked in the DMAP. I think pretty easily. It would just have to recognize some of the scan profile options.
I was wondering, like, I don't, who up the front end, like, how the arguments pass, or they escape any kind of insider there?
Sure. So the scan when you run it, the host box, I'm guessing what you're referring to, how you can do it. So it can do comma or line separated, and it can do any format that Nmap accepts. So it's actually passed as a raw Nmap command line via the DMAP protocol. I did a little internal bug bounting in my team to hopefully try to find anything obvious, but it's all properly escaped out and checked. The input's checked. It strips it on the client side to make sure that nothing bad goes wrong.
I'm thinking, like, some scans require roots.
Sure. Yeah. Obviously, it does a whole bunch of input filtering. Django, I do like regex matching on the host, and it actually the regex matching restricts it sometimes too much. If you have international domain names, a friend pointed out that if you have international domains using Unicode characters, like my regex won't like it and kick it back. But it does both client and server side when it gets to the host and before. Sure. Yep. Oh, there you go. Sure.
So if you have just an Nmap script, is there a way to automatically execute to your servers or automatically have to connect all to different servers?
Yeah, so the Nmap's done on the client. So if you had like NSC scripts, I played with this a little bit. You would actually have to make sure they get downloaded during the install of the client. So that's why I prefer to use like stack scripts on Linode or some type of automated method of installing the client. You could build it into like the shell script I have, but they have to be on all the clients because you don't know what node is going to pick up your scan at the current moment. So NSC scripts are kind of buggy with this just because of that matter. I did, so when I did the 100 nodes, I was doing some scanning around like VMs I had on the internet. I didn't actually kick off like during the load testing with like class Bs or anything. You know, depends on your definition of what's legal in the scanning world. But we've used this on engagements, and you know, I've tested with customers' environments, and I never noticed any latency issues on my side. It takes the same as if you're running an Nmap that's broken up. I mean, it's not doing anything super fancy beyond just distributing that Nmap scan. So. That was the one feature I wasn't able to get in before this con. I actually wanted to do that. That was the next thing on the list to integrate is actually build in a checkbox to allow you to automatically break up the scans and combine scan results. I'm hoping that would be the next big feature I come up with in the continued development of this application. So at the time, no, you would have to use a tool of your own to break up the scan host list and put it into multiple scans, which is definitely not ideal. But that's kind of the future of where I see this going for the next big step. Sure. Sorry, the question was that he asked if the scans could be automatically broken up. So if you're scanning a class B, could the tool automatically break that up into multiple scans for the nodes to break out? So automate the efficiency. Right now, it does not do that.
Okay, one more question.
Way in the corner, all the way in the back. Yeah, like I said, at this time, there's no breaking up of the scans. I'm sorry. The question was. So the question was, could you round robin or break up the scans to different nodes? Is that correct? Okay. Yeah. So at the time, there's no breaking up of the scans automatically. It's done by you, and it's automatically goes out to a node. So you don't get to like select, or you don't get to let it bounce around the different nodes. Again, that would be something in the future. Obviously, that would be good for like a red team situation externally, where you're trying to make it look like it's coming from different places. At this time, it doesn't do that. Thank you, and if you have any questions, let me know.
DA? Right? All right. So I was watching SixDub's talk there, and I was noticing in his web browser where he was going. So while he was talking, I was sitting there trying to go to what was it? It was minions.sixdub.net, but it didn't work. So.
Checking that for default creds.
Yeah, I was going to check it for default creds. All right. Oh my God. All right. So I have two more of the awesome USB condoms. All right. Yeah. Right side. All right. So we'll do one over. All right, over here. Awesome. All right. So as he gets set up here, a friend of mine, Tony Robinson, he's on Twitter, DA_667. And I don't know, I've actually suggested to him several times that he should charge, like he should make his Twitter feed private and then charge for access. Because it's a threat intel feed essentially. So.
By the way, if y'all are interested in talking about that, I'll be around. I shouldn't be too hard to spot. I'm in gray and orange, so more than willing to talk. Okay, and 4, 3, 1.
You good? All right. DA.
Hey. Hello and welcome to Firetalks. I am Tony Robinson, or DA667. My talk is Confessions of a Malware Hunter. My obligatory Who Am I slide. My obligatory Who Am I slide. I am an individual who loves to do network security monitoring. That's most of my background. I am currently a senior security analyst for a rather large power holdings company, which basically just meant to them was like, hey, here's the IDS, here's your creds, you can't do worse than what we have, do what comes natural. I get all sorts of freedom. Voice of God. And my first confession is that I am an amateur malware hunter. So, this happened to me a couple of days ago. This is my greatest accomplishment. My Twitter feed that Grex was talking about, I've actually been classified as a social media threat by ESET, so I have an achievement already. So, moving on, what do you mean amateur malware hunter? This isn't my day job. This isn't something I've been trained on. I don't spend days in a debugger and Ollie debug. The pin talk, while I loved it, confused the hell out of me. I don't know IDA like the back of my hand, and I don't have money for IDA Pro. So I do it for fun anyhow. Let me show you some of the cool stuff that I found. Most of this talk's part of this talk is going to be cool stuff that I found just within the last year since I became a security analyst, and the other half is how can you do this too with limited knowledge or advanced knowledge. So this particular slide, I have a lot of IDS sitting at the border on my network, as does everybody else. I get a lot of probots. I get a lot of systems trying to exploit old vulnerabilities, and even some of the new ones like shell shock. I see a lot of remote file inclusion attacks. The furthest screenshot all the way over there is a list of IRC bots in a channel close to about 500 or so when shell shock was becoming a big thing. And actually, no wait, that was just after New Year's this year. I got a couple of hits on my IDS and was looking at that. So yes, there are 500 bots sitting in a channel waiting for commands. The top picture right there is the script that I pulled down just from looking at the IDS logs and determined where they're calling back to. And the bottom is my Twitter feed, and I'm telling everybody, hey, guess what? There's fun stuff here. Go say hi. So this is another one. This is a little bit more interesting because in addition to the IDS and NSM stuff, I do a little bit of Google dorking for fun too. Let's not get into the legalities of that. But I found interesting stuff. I've Googled dorking that probably shouldn't have been there, and one of them was this. Show of hands, how many of you have seen Silence's op cleaver reports? Okay, a couple of hands here and there. They're another APT. The report came out a couple of months ago. By the way, APT drink. Came out a couple of months ago. They were coming out of Iran, and just for, more or less, just for fun, I was Google dorking for open anonymous FTP servers because apparently those are still a thing in 2015. And this is one of the results. I know that you can't see very well, unfortunately. Some of the file names are a little bit tiny. But this is an open FTP server on a hosting provider out of California. I worked with the hosting provider for an entire week for them to get their shit together, so to speak, and they decided to do nothing, so I started sifting through the data. One of the more interesting things that I found was a file called koc.rar. Hey, I opened that up. It is a full network map. It is a full enumeration of the AD domain for the Kuwaiti National Oil Company. And I was messing around with that for a little while, at which point I said, hey, the CFAA is a thing, I probably shouldn't be holding on to this. And I get a hold of the FBI through a couple of very good connections who are working the con. I love you very much. And got that reported to them 6 months before the Silence report came out. And I was sitting on top of apparently an APT dead drop and never knew it. The next one that I have here is a little thing called Phantom Train. One of my buddies said, hey, I've got this malware. This is a very common thing with people who are on Blue Team Incident Response who this thing is infected with malware. Well, we don't have time to investigate what it is necessarily. We just need it off of our network. We need it off of our hosts. Somebody's like, well, I don't have the time to look at it. Here's a copy of what it is. Here's some PCAPs that I have. Why don't you have a look at it and tell me what it's doing? And this is all just straight up dynamic analysis. This was, it looks like some sort of a Zeus or a Zbot variant that actually uses Phantom.js to scrape, monitor user activity, scrape their creds. And as you can see in one of the photos there, it's a directory listing of a server. Those are the dependencies for Phantom.js and a bunch of the other tools that the malware uses and installs on systems. A lot of the stuff up here is just the command and control traffic, not encrypted, just saying, hey, you can get your dependencies here, you can talk to these guys for command and control. Some of the botnet controls will ask to proxy traffic off of it or proxy your traffic to here so I can sniff everything that you're doing. A generally nasty thing, and I wrote up a couple of NSM signatures for it and distributed those freely. And last but not least, one of my favorite ones, I named this one Operation Aluminum Knife Party, because if the NSA can have ridiculous code names, so can I. So, there are a bunch of actors out of China. China apparently likes to scan and break our crap all the time and break in and take advantage of shitty passwords all over the place. So these particular actors, they like to use SSH brute forcing and other recently released vulnerabilities to access as many systems as they can. They drop something on there called HTTP file server and serve out a bunch of these binaries to just add to their botnet. These are just DDoS binaries and various other types. Well, another one of my friends said, hey, I found this. This is pretty interesting, and I had about 50 megs worth of executables sitting on one of these servers. If the very bottom corner there, you can't see the text very well. I apologize for that. Some of these are post-exploitation binaries that they had. That particular tool is called wsyscheck, and when it was dropped on the system, it would do a full profile of the system. Here are things that are registry run once keys. Here's your registry run keys. Here's your appinit DLLs. The ones that are highlighted in red right there, those are drivers that could be a threat to the attackers on the box, such as npf.sys that Wireshark uses, or Windows TCP dump. Stuff like procmon23.sys for process monitoring. So this is like a post-exploitation. I want to look at this box and I want to see if there's any threats to my operation sitting here. So I've been working a lot more with those tools, and I'm still trying to do some analysis on them. I don't have any free time, just like everybody else at this con, so process is slow. The last one up in the corner there was kind of interesting too. That guy, CN Game Control, whatever they called it, it listens on port 8009, and when you try to connect to it with a web browser, it gives you a 404 page. You connect to it with Netcat and you give it a password of, pardon my French, fuck, it would give you a backdoor shell automatically. I was like, this is all done through dynamic analysis. So these are just a couple of the fun findings I have found within the last year. Now I'm going to get into, I'm an amateur malware hunter, and so can you. We're going to make science. So what are the tools that you need to make science and be an amateur malware hunter? A cheap VPS, some version of an IDS, Snort or Suricata, and Barnyard 2, and you just need one of the analytics GUIs that are out there for free. There are tons of them available. And a little bit of honeypot software, coincidentally enough. Honeypots are a big thing, and I have a lot of fun with them. So we'll start with cheap VPS. A lot of VPS providers these days have super cheap solutions. The crappier they are, the more insecure your neighbors are, the more fun it is because you get to see the stuff that's attacking you. So in my personal experience, some of the more interesting hosts are the ones that are more bent towards privacy, particularly Denmark and Germany. I hate Hetzner Online AG with a passion. I hate OVH with a passion because they both tend to host massive amounts of malware. And every so often I'll see something out of DigitalOcean and Linode and a couple of others here and there, but cheap is good, and if your neighbors are terrible, then you get to take full advantage of that and look at what they're doing. So the next part I'm going to go into, this page is just a pile of text on the screen. I don't expect you to memorize all these numbers. These slides will be available later. But my background is in NSM, and in addition to honeypots, I use a lot of NSM to do the hard and heavy lifting for me. If I get alerts, then I get PCAPs. If I get PCAPs, these are particular signatures or particular attacks that often and times include the payload with the attack itself. So that's something for me to take a look at, say, is this something new? Have I seen this before? Has anybody seen this before? And just go to town on it. Because oftentimes, they'll have, here's a remote file inclusion, I want you to wget to this website. Well, why don't I wget to that website myself and just pull down whatever you're asking me to? It's often that simple. So there's a couple of categories of rules that I had on the page. Again, there's shell shock. Everybody knows how vastly that's been exploited since it was announced. Another interesting one I see is PHP remote file inclusions. Those have been around since 2012. There are still servers that get hit with that a lot, and even better yet, still servers that get listed into command and control channels that haven't been patched that are still vulnerable to that particular type of attack. The bottom two there, the bottom three there, generic iframe injection and exploit kits, those are more if you have clients that you want to monitor, if you want to look for new exploit kits out there in the wild or interesting things going on in your users' web traffics. 9 times out of 10, when you see an exploit kit on the page, if it isn't obfuscate, if it isn't a boatload of Java obfuscation, it's some sort of an iframe on the page that's invisible or put in before the doc type header on a page or something else of that nature that just shouldn't be there or just isn't right. And those are a huge list of IDS signatures provided by the VRT or Talos or whatever the hell they're calling themselves these days that they give out for free along with the Snort IDS software. The bottom one is just kind of if you know of any other vulnerabilities that are vastly exploited out in the wild aside from MS-08 and every worm known to man. Just enable the rules for them and have it log the PCAPs. You will never know what you're going to get. I'm going to touch on honeypots a little bit here. Show of hands, who hasn't heard of Kippo? I saw one. No, it's fast and easy, Python-based SSH honeypot. It's a good compromise between a high interaction honeypot and a low interaction honeypot where you can't really emulate a whole lot of things. It's very customizable, it's easy to spin up, it's easy to run, and even better yet, it's very easy to modify to configure that fake SSH honeypot to have a profile of a different Linux host, just as easy as modifying the kippo.config file and a couple of command output files that are included with the Kippo project itself. Modify a few files, change your host profile, run SSH TACV to get whatever version of SSH your server is running and dump that into the config file, and hey, it looks, instead of looking like a generic Debian 5 box like a default Kippo install, you look like an Ubuntu 14.04 box, just like that. A couple of other honeypots I've been working with. I've messed with Glassdoff a little bit, just very recently I've been messing with it. And Glassdoff is a web-based honeypot. It's kind of interesting. It injects a bunch of interesting words and text output into the middle of a web page to cause web tools to freak out and interact with them more interestingly. It'll say, hey, I want to access /PMA. Well, hey, /PMA is right here. Why don't you have fun? And there is another guy by the name of eBrinkster on Twitter. That's his handle. who started an XRDP honeypot. XRDP is just a port of remote desktop protocol to Linux. The only difference in this version is that it's more or less been hamstrung to where it will never authenticate properly. It will log IP addresses, usernames, passwords used, and also the keyboard mappings for people trying to hit your remote desktop honeypots. A lot of fun. At the end of the talk here, I got a couple of fun links, a couple of other posts that I have written up about doing automated Snort installations through other tools that I've wrote, using Snort as a part of your intelligence platform or your honeypots, using that information that you have to augment your amateur malware hunting. A little bit of information here on Kippo, on making Kippo more believable, and just generic malware triage. Feel free to go ahead and take a look at them later. Once again, I'll have the slides out there. And have fun being an amateur malware hunter with me. Any questions?
Is the blue text any easier to read close up?
I'm sorry, you want me to go back to this, to the blue text?
Totally legible from back here.
Oh, I'm so sorry.
You said you're posting the slides, right?
Yes, I will be posting the slides online. If you have a Twitter account, that is @DA_667. I will post a link to those slides. Any other questions? Well, thank you very much for having me, and I want to thank Rex for inviting me to come up and talk.
I'm leaving this up here because Chrono's going to be using this laptop too.
What?
Oh, party foul. And wait.
I need to turn my laptop on.
No, you're good. Wait for it.
What are you trying to do?
I'm proxying out, don't worry. I'm just getting to his slides.
Okay.
I have a backup if it doesn't work.
Oh,
Cool. There you go.
Awesome.
Alright.
I'm gonna leave that.
Nice. All right, so just a few more things here. Oh, the handicap. Oh, man, making me feel bad. All right, so this is the final throwing star land tap. So, wait a minute. All right, so where we go? All right. All right, oh, did he get it? Okay, so next up is a talk on SSH ranking. It's a honeypot thing. All right, Pronto, but it's Pronto Moo, right? I think they missed.
No, it's that. That's good.
All right. Anyway, this is Pronto, so a good friend too. Pronto.
Oh,
Yes, clap. All right, talk
let's see. How do you use this thing? Okay, cool. Macs are hard.
All right, that's good enough. All right, so I've been kind of working on a Python project that it's called SSH ranking. And you can contact me on Twitter, moo_pronto, or my email's up there as well. So first, botnets, they attack all the time, and why pay somebody else for a threat intel feed when you can just look at your own servers? So that's just an example of, oh, am I not? Sorry. Is this better? Okay, oh, okay, well. I can hear myself now, that's creepy, yeah. Yeah, so they hit a lot. This is one of my Linode servers, 62,000 times just on auth.log, and I do have log rotate on.
And that's only failed attempts, so yeah, they attack. So what you should do is take SSH off the internet, don't listen, or fail to ban or whatever, use VPNs. But if you want to track all that stuff, you can either use Kippo, which probably should if you want to get your own intel feeds. But I made my own project that just parses auth.log because I like keeping my own SSH daemon listening so I can get to my own server. So here's an example of what the website kind of looks like. So the IP address, let's see, I can barely see. When did the, so the IP address, RDNS, I used to have the usernames listed on this page, but so you see that host from France hit me about 2,000 times, 2,000, and that's just in the past 24 hours. So that's a 24-hour span. I get hit a lot, so I'm going to go to the website so you can see a live example. That's not at all readable. Command plot? All right. Is that good? Is that good? All right, cool. You get most of the stuff. So, quick example. I'm going to go to this first one from our favorite place, China, because they don't know how to not attack or secure their own servers so people can attack through them. Like, people should teach China, update your stuff. Please do it. All right, so this is a very simple one. Also, this is best viewed in Netscape. But yeah, so you can see over here when they attacked, how many times for that day. So they hit me just that one day. Let me try to get to one that actually has a bunch of different users. All right, so Hong Kong, they've been hitting me recently. Like, they didn't hit me before, and suddenly in the past couple months, a lot of IP addresses from Hong Kong have been hitting me. So, well, that's just one user, but yeah, there's a lot of users. Like, some servers hit me with like a couple thousand users, and the neat thing with that is you can start seeing patterns. So this one group of IP addresses all use these set of usernames. So either it's just some crappy automated, like, let's start doing brute forcing, or in some cases it's been accounts they have set up on the server so they can get back in. I've seen that a handful of times, which is really cool when that happens. What was that? Yeah, India has hit me. They haven't recently. I don't know, it goes in and out. So one other thing I do is I nmap the people that try to brute force into me. And they agree to this because when you SSH to my server, there's a pre-banner that says, if you SSH to me too many times, I'm going to nmap you. Yeah. You should read the terms of service. It's a very short one, but yeah. So things I find. What?
It's like stand your ground, right?
Yeah, sure. I'm sorry. I don't know. Drink. So things I find on popped servers. Tomcat, our favorite thing to get shell onto servers. Plesk is all over the place. And Webmin, which is, I don't like that one. But so one of the coolest places that hit me is the Royal Malaysian Customs Department. It was one of their actual servers that were hitting me. I was like, that's neat. I nmapped them. That's all I did. I sent them an email too. I was like, hey, you should fix this. They never responded. I never actually went back and checked to see if they fixed anything. I kind of doubt it. So I have also, Tony previously said, HTTP file server. I found about 9 different Chinese hosts. And
I found this almost a year before I knew anything about what was going on out there. So get him a hand.
So the unfortunate thing about that is I found it and didn't know what to do with it because they had some pretty cool binaries listed on that. Let's see, so they like post-exploitation, like he was saying, a malware one, and a DDoS program as well. And if you want those binaries, I have them, some of them on my blog, pronto185.com. So that's what HTTP file server looks like. It's a Windows program. Sometimes it's in English, sometimes it's in Chinese. Sometimes there's no files, sometimes there's a whole lot of them. It's pretty cool to get the stuff from there. And this is just, I ran that command that tells you what type of file it is. So like there was actually a file name called number1, and then there's executables, and a C source one with a whole bunch of stuff. So you actually got the source to their code, which is pretty nifty. So you didn't even have to reverse engineer it. DDoS and DDoS 64. I've looked a little bit into those, but not too much. And this is just what it's kind of like when you find one of these HTTP file servers. You go to it, and by the time you start to go download the executables, they're gone. And I missed to get the malware they're trying to host, but it's sad when you don't get that. I'm going to show you one more or a couple more pages on the actual website. I'm not used to Macs at all. So,
I'm sorry.
yes, how dare you let me use your laptop? So, here's this. I've actually learned a couple new countries I didn't know existed because of this. That was pretty cool. And then I got stuck on a Wikipedia loop and didn't do anything. But so, China's going to be very obvious. Boom. Yeah. Like, seriously, China? We should revoke your well, yeah, China's drunk. Let's use all of our IP ranges. Okay, let's just block China. But Egypt was kind of surprised me about the number of ones. It's small, but El Salvador. Most of the French ones is Tony's favorite company of OVH. And then the neat thing with Hong Kong, if you look at those, is there's a /24, and like 90% of that /24 hit me. And I've talked to people on Twitter, they've hit a lot of other people on Twitter as well. Or like, they've noticed Hong Kong's thing, just like, this is your entire IP range. But yeah, so they hit a lot. I can show you a couple more pages. Any questions while I'll get to the next page?
Any IPv6?
I do listen on IPv6. I've never once noticed anybody try to SSH to it. So if you're able to, just put your stuff on v6 and nobody's going to know it's there. For now. So hopefully that changes. So a couple other things I do. Everybody's seen IP Viking? It's very cool if you haven't. There's fancy maps of their massive honeypot network they're running. So it's to get that information to your browser, it's just a WebSocket, and you can use Python to connect to that and just grab all their data. Because they just put the IP address, what type of attack it was. So I've been correlating with if it's an IP that has hit my server and has come across IP Viking as I'm listening to their WebSocket. And it's a pretty big list, so if they hit me, it looks like they're also hitting IP Viking. And also there's a bunch of honeypots that post, hey, I'm getting attacked by this IP address, and they post that to Twitter, and I'm gonna start grabbing that data into, and it's like, this IP address has been hit by all these people, it's definitely really bad, somebody could look into it. So, any questions, comments?
Do you have an API to pull data out of your data set?
I'm working on that. That's something I do want. If you want the data set, I can just dump the SQL. It's like 2 million rows right now. You can just have it. But if you want all the IP addresses, just go to the GeoIP page. That's a very easy way. You can just parse that for now. Yeah.
How big is your log file and how often do you wipe it out?
So the question was, how big's the log file? I actually don't look. I haven't run out of space on the server, so it's not a concern to me. Yeah. He said sysadmin, I guess. It's a VPS I have on Linode. I don't really care about it. But because it's log rotate, there's a massive trail of like log.1.2.3.gg, and there's like 40 of those. It's crazy.
What do you think the future of crowdsourced threat intelligence looks like?
So this was a future of crowdsourced threat intelligence. I think I want it to keep on growing and people collective data to distribute for free. I like the direction it's kind of going. And if we can get away from like, hey, pay me for my threat intel, it's like, no, you share, everybody shares. It will make it a much easier place to track the botnets and hopefully get them shut down. So.
Is there a way for us to get you data from our honeypots? And are you just only running this on one VPN?
So the question was to give me your data on your own honeypots and.
Are you only running this on the L-Node VPN?
Yeah, I'm currently only running this on one. I was running it on a server on OVH one for a while, but I stopped that. I need to make the whole program better so it can have multiple feeds coming in. And I do want to in the future be able to have a whole bunch of people like just send me their attack logs if you want to, and I can add that into this as well. And most of the source, old versions of it are on GitHub. I need to update that, but it's there if you want to play around with it. Back there?
Unless you need to take action from the data, an easy way to aggregate it is just have syslog wherever within your control point you want to place it, and then it'll go to the same log.log.
So he's basically saying set up syslog correctly and have a central syslog server and parse that. Yeah, I should do that. That would work really nicely. And then I can just parse up in one place. Yeah. What? Yeah, and this is just a side project I've been working on, so yeah.
Did you say that was publicly available then?
Yeah, the source code is, if you go to ssh.rank.in, there's a link on the top that says GitHub. What's on GitHub is older. I need to update it, but it's there. And it's mostly in Python. And anything else, or? Yeah. First, I'm going to show you a page of, I take screenshots with Phantom.js of web servers. I'm going to quickly scroll down this. There's some kind of interesting things in here. Right this is the Royal Malaysia Customs Department. Yeah, there's a whole bunch of stuff. Most of it's just Plesk or one of the other server management things. And contact info.
One question. Did anybody have any other questions? Nope.
Thank you.
Thanks.
Yep.
Just one more. That's it. All right, so the final two giveaways. Oh, everyone's leaving now. Maybe I should wait till after the last talk.
Was this yours or was this?
That was mine. All right, so we have the final USB condom thingy that's really good. So I'm gonna go. All right. This is the last, and I think I just might keep this, but this is this is the last YubiKey Neo that I have. So let's see. I threw the last one over here. I see more hands up over here. So. Wow. Wow, that went fast. Fortunately, the YubiKey thing is like really small and light. Did it just fall out? Yeah.
Yeah. I don't intend to throw that at me.
Yeah. But no. And an iPhone 6. All right, see, I gave away the gifts, like now everyone's gonna leave, right? All right, so the final talk that we have here at ShmooCon 2015, the topic is resource public key infrastructure. So a very complex topic, and we have Andrew Gallo. Did I say that right? Gallo, sorry. Andrew Gallo that's going to be talking about it. Andrew?
Thank you. Thank you, and thank you for sticking around for the last talk. I always hated the conference talks right before lunch where the guy had some corny joke like I stand before you in lunch. Well, I have the unenvious position of standing between you and free beer. So luckily for you, I talk fast, hopefully not too fast to get my point across. Resource public key infrastructure is a little bit different than many of the talks we've heard today and last night, and that it's not about malware or host infection. It's about securing the routing infrastructure on the internet. So be kind to an old routing guy. Not necessarily. I'm more of a network guy than a security guy. I don't have a obligatory about me slide, so that'll have to suffice. So as cliche as it is, the internet really is a network of networks, and it's a bunch of organizations that agree to abide by the same rules. It's self-organizing in that there's no central authority. Currently, on the IPv4 internet, there's around 500,000, 510,000 destinations. And by destinations, I mean networks or prefixes, not individual hosts, obviously. And a network could represent anywhere from a handful of hosts, around a couple of hundred, to several million. So this is a diagram, a relatively recent diagram of the internet, or something that looks very much like it, because the internet has properties of other large-scale, long-tail networks. So the question is, how do you find your way through 500,000 routes? How do you know to get from your host to one of the servers or hosts that we just scanned or saw, or trying to attack something? So we use the Border Gateway Protocol. It's the way network operators share information about the topology of the internet. And as you see, the guy in the space-looking suit for protection is the Border Gateway Protocol. This was taken when I was on a mountain biking trip in Colorado, and some space-looking guy kind of landed on Earth and showed us the way to Utah, and that's how we found our way. BGP I'd classify as a wildly successful protocol. It was first standardized in 1998 with a relatively recent update in 1994. It has not really changed much since then, but still has been flexible enough to carry everything from IPv4, IPv6 with no real extensions, unicast, multicast. It is used both on the internet, in the enterprise. It allows people to pass security information using BGP flow spec. It is a highly configurable and malleable protocol. However, BGP is based on trust, like most of the protocols we grew up with, like Telnet. In the clear, it's been replaced by SSH. HTTP has mostly been replaced by SSL. SMTP has hopefully been mostly replaced with Start TLS, or at least added that so it's not in the clear anymore. But BGP still remains a protocol based on trust. There are some mechanisms to protect the protocol itself, such as MD5 hashes, which are passwords on the sessions. Time to live security, which says I'm not going to accept sessions unless they have a specific TTL, as well as access control lists, which control who can talk to my BGP speaker. Again, these only control or protect the control plane itself. When BGP was standardized in the late 80s, the internet wasn't a thing. It was still NSFNet, and it was based on people knowing who you were in order to set up a BGP session. The problem we run into in this situation is there's no ability to determine who is who on the internet. I was going to put in there the classic cartoon of no one knows I'm a dog on the internet. What happens is there's no hierarchical routing or addressing on the internet. Any IP block can exist anywhere on the internet at any time. This is either explicitly or implicitly a reaction to the very centralized, very prescriptive public switch telephone network, which the internet is mostly supplanted at this point. On the one hand, this solved the problem of decoupling location and identity, but it introduced the problem of scaling as well as identity control. Scaling is a whole other topic. Identity control is what we're talking about today. How do I know you are who you claim you are from the perspective of advertising IP blocks? In the old days, as legend has it, John Postal had a spiral-bound notebook and would write down each organization's IP prefix and their assignment, and that's how IP addresses were assigned. This map is a 1987 map of the NSFNet, and it is the only official documentation I have for my organization's assignment way back in the day. I'm sure there's an email from John Postal somewhere. I'm sure it also doesn't exist anymore. The registry that covers the United States, AARON, has since used the carrot and stick approach to get organizations like mine to register and sign something called the Legacy Resource Agreement so that we no longer need to rely on this map. However, this is how informal IP address assignment was way back when most of the addresses were assigned. So if that's how they were assigned on pen and paper, how are they validated? Well, very seriously, they weren't. BGP, again, is based on a trust model, and there's nothing in the protocol to allow for the validation of identity. There's no relationship between an IP prefix, an autonomous system number, and the organization that's advertising it. The current state of attempting to use this information or to protect yourself from misidentification is to use internet routing registries such as the Routing Assets Database, which is a phenomenal resource, Whois data that's run by any number of organizations, and to collect this data and then put it in a format that can be used to form routing policies. The problem is the IRRs, and there are many of them, don't necessarily have the same information. The data can sometimes be out of date and erroneous. So what happens when things go wrong, when this data is invalid or unreliable? Well, there are any number of hijacking, classic hijacking stories of BGP on the internet. I've highlighted a couple of them here. The Pakistan YouTube hijack is probably the most classic, where the Pakistani government issued a letter to their largest provider and said, we want you to block YouTube. That black hole leaked to the internet and caused massive outages for YouTube. It is still debated whether or not that's a mistake or intentional. That's irrelevant for this conversation, but it shows how easily a small part of the world, or the small part of the internet's policy, can leak and disrupt the entire internet. An ISP in Brazil leaked the full table. Luckily, this didn't get very far. China Telecom did the same thing. Not the whole table, about 37,000 routes. The most interesting one happened last year, and I'm surprised it's not making more news. Dell SecureWorks, who is here, and I'm not plugging them, I'm just saying they did a great paper on this. A bunch of folks did a BGP hijack on Bitcoin miners that were hosted in AWS and stole some money. It is a phenomenal analysis of both BGP hijacking and Bitcoin mining. And Dell SecureWorks, if you look up Dell SecureWorks BGP hijacking, I'm sure you'll get to that page. This happens primarily because of mistakes. People fat finger something and it propagates farther than it should have. It could be in the case of you want to just clobber somebody's network and black hole them. It could be for fun and profit, as we see in the Bitcoin example. And it could also be the fact that you're trying to direct traffic to you so that you can sniff it and then send it on its way so that most people wouldn't know that you're doing this. That takes a little bit more advanced action, because you have to mess with TTLs, and is not necessarily something that is seen very often. Real quick, a couple of diagrams on how this works. BGP, there are about 12 different ways to select a path. One of the ones at the top of the list is shortest path. So if you have a network down here, 172.16.00/16, and somebody else claims it, the shortest path wins. So the person up here in the upper right-hand corner, the client, will follow the shortest path to get to you. You have now just stolen that address block. You could set up fake web servers, send out spam, whatever you want to do. More insidious, and this is just how network routing works, more specific prefixes that have longer masks, such as more bits, will win even if it's a longer path. The current state of the art, as I mentioned, is to use whois data, letters of authorization, and have operational staff manually check this, hopefully in a semi-automated fashion at least, to check whois data and create route filters. It doesn't really work that well, as we've seen. There are some BGP monitoring services, such as BGPmon, Cyclops, I think Thousand Eyes does something like this. And if you're the victim of one of these hijacks, your options really are to call your upstream, post to Nanog, and depending on the mood of who's monitoring the list at the time, will depend on how well that will work. Or you could attempt to advertise more specific routes of your own address block, which is what YouTube did in order to get back the addresses from Pakistan. So in comes RPKI. Resource Public Key Infrastructure is a relatively new technology that is meant to provide a cryptographically traceable trust chain from the authority of the IP addresses. It's an extension to 509 that carries IP address block information, and it is called a route origin attestation, sometimes called a route origin authorization, or ROA. The IANA, run by ICANN, is the source of all addresses, but they don't hold the single root certificate. It was decided that each of the registries, and there are 5 of them in the world, would hold self-signed certs as the root of their resources. 2 modes of operation. There's hosted and there's delegated. And in the hosted environment, the registries all run their own PKI infrastructure. Delegated as model is more appropriate for ISPs that need to delegate and subdelegate address blocks. ROA contents include who my autonomous system is, or who am I, what the IP address block is I'm advertising, and validity dates. So once you've signed your routes and told the world, I am authorized to advertise these blocks, what do? Well, that's all you really need to do if you're concerned about protecting your own resources. If you want to check for other people's validity, you now need to go and collect the ROAs from these things called trust anchor locators, or TALs, which are what the regionals run in order to pass these certificates from the originating party to the relying party. The key here is that there's no cryptographic processing on the router. It's all done by adjunct machines, so that you don't need to worry about processing load on the router. You don't need to worry about that for RPKI. You do need to worry about that for secure interdomain routing, or CIDR, which is an effort in the IETF working group in order to do path validation. If I didn't make this clear before, RPKI is about origin validation, in that you are allowed to originate a specific IP block from a specific autonomous system. This is a block diagram of the setup. There's some crypto engines in the back. They feed to the trust anchor locators, and you as an operator then connect to the TALs, pull down those ROAs via rsync, do some crypto processing, and feed digested information to the routers. I left ARIN, which is the North American regional, in gray. There's an explicit agreement you need to sign in order to, or at least click through in order to get the ROAs. That's a whole nother discussion for a day. If you're on NANOG and you remember about a month or two ago, there was a lot of discussion about that. I apologize, I started that. I should have let John Kern know ahead of time his email box was going to explode. Basically, ARIN says you need to indemnify us, hold us harmless, and defend us in the event that something goes wrong with the system. Again, another talk, but it does raise some interesting questions about the legality or the legal implications of this system. Routes have 3 states. They're valid, which is good. They're unknown, which is the state of most of the routes today. And they're invalid, which means it's either an invalid origin, an expired certificate, or it's possible that there's a valid ROA for another part of that prefix, such as a summary route, that just doesn't cover the route you're advertising. So what do you do with this data once you have it? Well, right now, nothing. 95% of the route table is unsigned, so you're not going to be making policy decisions. In a fully deployed RPKI environment, what do you do with this information? Do you reject invalid or unknown routes? Do you set local pref low, which says I don't want to use this route? Do you set communities? What do? That's still up for operational debate. And this is a place where if you want to participate, developing operational best practices are still up in the air. So this is an area where you may want to take a look at. If you're interested in doing this, study RFC 6483. It discusses what the states of the routes are and how they get into those states. There are a lot of good public resources. This is a BGP validator that RIPE open sourced. RIPE, which is the European registry, is a leader in this space, although this particular one is hosted by LACNIC, the Latin American and South American regional, which also has the most ROAs in the table. You can go to these and check any prefix on the internet, and it'll tell you if it's unknown, valid, or invalid. There are also some great command line tools. There's 2 routers I have in the resource slide. You can secure shell 2, and they're Junos routers. You can run some commands and see what it looks like from the router's perspective. BGPmon also runs a Whois server that lets you look up the validity state of any prefix you want. So we've solved everything, correct? Well, not really. We've only solved origin validation. The CIDR working group at the IETF is working on path validation. And there's still work to be done with RPKI and again, operational best practices. And the best part is, RPKI, like all new things, introduces some vulnerabilities. These trust anchor locators become valuable targets for both denial of service as well as attempting to own them and provide false data, which is partly ARIN's concern. And there's also the bootstrap problem of how do I trust the path to the trust anchor locators. This is I wonder if it's a Gödel incompleteness problem concerning the internet. A lot of interesting work going on in this space. There's slow adoption. Obviously, the graph shows RIPE is the leader in terms of space signed by ROAs. And lastly, if you are not a BGP speaker, it doesn't matter. Your organization uses general internet access, even if somebody else manages it. You should be asking them, when are my routes going to be protected? If you have applications hosted in Amazon, Azure, any other provider, you should be asking them, why aren't my routes protected? The Bitcoin mining attack was done against AWS IP space. Some resource slides if you want to check the web page I showed, as well as go and get into a router. I'll post these slides. And here's some contact information. So again, thank you for staying so late, and enjoy the rest of the show. Any questions? Any questions you can ask me now, or just hit me up on Twitter. So thank you.
This validates that prefixes come from the AS that it's supposed to?
Correct.
What happens if AS is hijacked to a false LOA or otherwise establishes a transit relationship or something like that?
This can't, if an entire AS is hijacked, this can't detect it. You still need to rely on the immediate upstream and peers to filter that inappropriate advertisement. It doesn't solve everything, but it is a very important step forward. Good question, thank you.
So thanks everybody, I'll see you next year.